Okay, it's time to watch out. This is video 3 for this particular section, and this one deals with lots of graphs. So here we go. Number 12 is asking us to graph the rational function, and we need to make sure that we include the graphs and the equations of the asymptotes. And so the function is f of x equals x squared minus 3 over x cubed. And the first thing we need to realize is that the asymptote, the vertical asymptote, will occur when this is equal to 0. So we get x cubed equal to 0, so that means x equals 0 is the vertical asymptote. While we're on the subject of asymptotes, let's go ahead and find the horizontal asymptote. We need to remember back to pre-calculus that if the degree of the numerator is less than the degree of the denominator, then it's what is technically called a proper rational function. And so y equals 0 is the horizontal asymptote. So we have asymptotes going this way, we have asymptotes going this way, but what we need to realize is that we need to see what happens right at this asymptote right here, the x equals 0. What happens? Does it go to infinity? Does it go someplace else? That's what we're looking for. And so we now have that capability, so we can say the limit as x approaches 0 from the left of x squared minus 3 over x cubed. Well, if we try 0 and keeping the fact that it's technically just slightly below 0, we would get, okay, slightly below 0 squared is going to be up slightly above 0, just slightly, minus 3 over, okay, likewise here, this becomes really close to 0, but this time it's going to be negative, because if we're just slightly negative cubed is slightly negative. And so we get 0 minus 3, which is equal to negative 3 over a slightly negative number, which will end up being negative over negative is positive. And since it's a number over 0, it's infinity. So we know as x approaches 0 from the left, it's going to look like this. We also know that it's going to have an asymptote over here. So we can realize that this is pretty much the way the graph is going to look on that side. Now the question is this graph going to look like this, or does it look like this over here? Well, that's why we test it. Test the limit as x approaches 0 from the right of x squared minus 3 over x cubed. Well, here it's slightly different. Squaring it is still going to be really close to 0 on the positive side, subtracting 3. But here, it's 0 positive is going to be really close to 0, but on the positive side. And so we get negative 3 over a very small positive number, which will equal negative infinity. And so we know it comes down here to negative infinity, and it's going to curve around like that. And so this is a graph, more or less, of what we need for this particular problem. Number 13, we're going to work our way through the exact same process and go from there. Number 13 is f of x equals 2x squared over 4 minus x squared. Okay, once again, we're interested, or we need to know the vertical asymptotes whenever 4 minus x squared equals 0. Well, factoring this out, we get 2 plus x and 2 minus x equals 0. So x might equal negative 2 here, or x would equal 2. So those are our two asymptotes. So at x equals negative 2 and x equals positive 2. So I put those asymptotes in and realize that I might have, something that looks like a parabola. It's not going to be a parabola, but it might have that same general shape. And then I might have some other curves like we saw in 12 just a few minutes ago. But let's deal with the asymptotes, the horizontal asymptote. Going back to last year, remembering that if we have the highest power in the numerator is equal to the highest power in the denominator, then we do have a horizontal asymptote, and that is just what is the leading coefficient of this, 2. It'll be y equals the leading coefficient of the numerator over the leading coefficient of the denominator, which is equal to -2. So we know that we have an asymptote of y equals -2. So we have several asymptotes going on here, and we have to think about what it's going to look. It might look like this, or it might look like this. Likewise, way over here, it might look like this, or it might look like this. And this might look like that, or it might look like that. We're just going to have to figure some of these things out. Well, to begin with, what we're going to do is we're going to find what is the limit as x approaches -2 from the left. In other words, what does it do on this side of this asymptote? So the limit as x approaches to -2 from the left of 2x squared over 4 minus x squared. Okay, -2 squared is positive 4. Going to be approaching positive 4 times the 2 is 8. Then it's 4 minus, okay, this will become 4. On the left-hand side, that would be -2.01 squared, so that's going to be slightly bigger than 4. So 4 actually becomes positive. And this is where you need to think very carefully through here. And so this becomes 8 over, okay, 4 minus 4 is 0, but this is 4 minus slightly bigger than 4, so that means 0 is going to be slightly less than 0, and so this will become -infinity. So I know it's going to come from this way. So I know that graph, part of the graph, is going to go like that. Now let's do the limit as x approaches -2 from the right. The limit as x approaches -2 from the right of 2x squared over 4 minus x squared. Okay, thinking through the same process. Anything squared is still going to give me 8, and it's actually going to be slightly to the positive side. This was slightly to the negative, as if it really mattered. And then here it would be 4 minus 4. And let's see, this time it's -2 from the right will be -1.99, so it's going to be slightly less than 4. And so this becomes 8 over, okay, 4 minus 4 is 0, but this isn't quite 4, so 4 minus almost 4 is slightly bigger than 0, which is positive infinity. Which means what's going to happen is up here, and my graph is missing, but eventually from when x is approaching -2 from the right, it's going to go up to infinity. And since I know it is going to be a shape similar to a parabola, but it isn't, it's more like a secant curve at this point, we will need to deal with other points there, and we'll get with that in just a second. Likewise, we can do the exact same thing. We can take the limit as x approaches 2 from the left, and going through the whole same thing, we will get from the left will be slightly less than 8, as if that really matters. 4 minus slightly less than 4, and so it will be 8 over 0 positive, and so that does go up to positive infinity, which should not be a big surprise because we know it's going to turn right back around. But we will have to get a value in here shortly. There's a real easy value to get. And then finally, we want the limit as x approaches 2 from the right of 2x squared over 4 minus x squared. And this will be 8 to the positive side, and 4 minus, okay, a little bit bigger than 2 is going to be just a little bit bigger than 4 when we square it, and this becomes 8 over, well, 4 minus a little more than 4 means it's slightly less than 0, so this becomes negative infinity. So down here it's going to be negative infinity, and we know that it's going to come up like this. So we have the outside parts. Now it's just a matter of what happens in the this part here. All we really have to do is find a value. Well, why not f of 0? F of 0 will be the minimum here, and so all we have to do is plug that in, and we get 2 times 0 squared over 4 minus 0 squared, or 0 over 4, or 0. So we know the point 0, 0 will be the minimum of that curve in that section. So with that in mind, let's come up here, and we know this part of the graph looks like that. We know it's going to come up to positive infinity and positive infinity by what we're told. 0, 0 is a point, so I'm just going to come down here and make a nice smooth curve through that, and then work my way back up so that it looks something like that. And so there is the graph for number 13.